Why is deep cloning JavaScript objects challenging? Imagine trying to make a perfect copy of a complex object in JavaScript, but every time you think you have it, something changes or breaks. That's because copying objects in JavaScript isn't as simple as copying a piece of paper. It's a lot more complicated. When you clone an object, you want a new object that is exactly like the original, but completely separate. No shared references, no accidental changes. But objects in JavaScript can contain all kinds of data types like numbers, strings, arrays, functions, and even special objects like date, set, map, or regular expressions. Some of these types behave differently when you try to copy them. For example, date objects turn into strings if you use a simple method, which means you lose the original data type. Arrays are objects too, so they need to be copied differently from plain objects. Functions are tricky because they are executable code, and copying them isn't straightforward either. Now, when you try to use a common method like JSON stringify and then JSON parse to clone an object, it works for simple data but fails for many cases. It can't handle functions, undefined values, symbols, or special objects like date properly. It also chokes on circular references, which are objects that refer back to themselves. This causes errors or data loss. Writing your own deep clone function sounds simple, but it's not. You have to check each property's type, clone arrays differently from objects, and make sure you don't get stuck in an infinite loop with circular references. This recursive process can be slow and bug-prone if not done carefully. Performance is another concern. Deep cloning large objects takes a lot of CPU power because it needs to create new objects and copy every property. Native JavaScript functions can do shallow copies quickly, but deep cloning involves many steps. Recently, JavaScript introduced a new function called structured clone. It can handle many complex objects, including nested structures, circular references, and built-in types like date, set, map, and regspec. It can even clone transferable objects like blob and file. But it still can't clone functions, which remains a challenge. When you're learning JavaScript and working with objects, understanding why deep cloning is difficult helps you pick the right method for your needs. For simple cases, shallow copies or JSON methods might be enough. For complex data, using structured clone or libraries like Lodash's CloneDeep is a better choice. Knowing these challenges helps you avoid bugs and unintended side effects caused by shared references. In the end, deep cloning is hard because JavaScript objects are so flexible and can contain many different types of data. This makes creating a perfect, independent copy a complex task. It's a mix of handling various data types, managing circular references, and balancing performance. Understanding these facts makes you a smarter developer when it comes to copying objects in JavaScript.